This is Laura Duncan with CSMS. Today we're going to discuss linear translations. First, let's recall how the graph of y equals x squared changes for the following. Please pause the video here. So in these quadratic equations, if we add 5 to the x squared value, it will move up 5. It'll go down 4 in the next one. But notice in the third example, it moves right to the minus 2 is inside the parentheses, and then the squared is on the outside of the parentheses. And then lastly, it moves left 3, and the 3 is inside the parentheses. Well, let's look at linear equations now. The graph of the line y equals x squared is given. You'll notice that it's linear because there's no squared, as we see in the quadratic equations. So in this line, the y-intercept is 0, 0, and the slope is up 2 over 1, up 2 over 1. We'll describe how the graph changes with each equation. Remember that when we're graphing a linear equation, we start with the y-intercept, and then the slope tells us where to move. So the y-intercept is the point 0, 5, and then we move up 2 over 1, up 2 over 1, or down 2, left 1. Please draw the line. Pause the video here while you do that. Now let's go back to the original equation, y equals 2x. While this is not the linear parent function because it has a slope of 2, it is our original function that we'll be comparing it to. So notice in this function that the slope is 2. The slope is also 2 in our new function. That means that these lines are parallel. Well, what's happened to it now? Since the function has plus 5, notice that where we started from right here at the origin, the new function has moved up 5 spaces. This is very similar to what we found in our quadratic functions. If we have a plus 5 and it's outside of the parentheses, then it will move or translate the function up 5. Now guess what happens on number 2? On number 2, it appears that it will move down 5. So let's go ahead and graph that. Pause the video here to make sure that those changes are true. So the green line did move down 5 from the origin. Let's look at number 3. What do you expect will happen here? What do you expect since it's inside the parentheses and it's a minus 5? Make a prediction. Now go ahead and pause the video here to draw your line. Now if you're having trouble getting started on how to graph this, one thing you could do is distribute the 2. So you can see you have a y-intercept of -10 and a slope of 2. So this line is still parallel to our original line, y equals 2x. So from the origin, we're always looking at what happened from the origin. From the origin, we shifted right 5. You'll be able to know that you shifted right 5 because of those parentheses. Now make a prediction on 4. What do you predict will happen? Well, in this scenario, because the plus 5 is in the parentheses, the function will shift to the left 5. Pause the video here and graph that linear function. Now that you've graphed your function, notice that from the origin, the function has shifted to the left 5 places. And you'll know that because of the parentheses. Now let's move on. Given the equation y equals 3x minus 1, write the equation if the graph is moved down 2. Well, what happened when we moved down 2? When we moved down 2, we subtracted 2 from the equation, and it was outside of the parentheses. So if we have our original equation y equals 3x minus 1, and we subtract 2 from that, now our simplified equation would be y equals 3x minus 3. And that's what it would look like. So please box your answer. Now predict what it would look like if we shifted the graph up 1. We'll take the original function, y equals 3x minus 1. If we shifted it up 1, we would add 1 outside of the parentheses, no parentheses. Now let's simplify it. Y equals 3x plus 0. Well, we wouldn't write the plus 0. We can see that that would be a proportional function. Now let's look at left 2. If we went left 2, we would be adding 2. However, they would be inside the parentheses. So let's start with our equation, y equals, and then if we move left 2, we're going to have parentheses moving left 2, so that'd be x plus 2. And then we would also have the original minus 1 in our equation. Now on this one, we don't want to simplify it. I want you to be able to see that this right here, this x plus 2, has shifted the graph left 2. Now pause the video here and take a stab at number 8, moving the graph right 4. Looking at number 8, if you have y equals 3, open parentheses, x minus 4, close parentheses, minus 1, then you are correct. Now let's look at the next equation. Given this equation, what form is that? That's in standard form. It asks what would be the slope of the line parallel. If we're looking for slope, we're looking for the m. Well, it's hard to tell the m, the slope, if it is in standard form. What could we do? Well, it's easier to tell the slope of the line if the slope is visible, such as in slope-intercept form. So we'll take this and please solve for y so that we can put the equation of the line in slope-intercept form. Please pause the video here while you do that. Now we found the slope of our original line. The slope is 3. We want the slope of the line that's parallel to our original slope. So if it's parallel, then it means that it will have the same slope. And so that means that the slope of our line will also be 3. What would be the slope of a line perpendicular? Remember, that will be opposite reciprocal. So the opposite of 3 is negative 3. The reciprocal of 3 is 1/3. So the slope of a perpendicular line would be equal to negative 1/3. Now for number 11, write the equation if the line is moved up 2. Well, remember this, y equals 3x minus 4 is our original equation. We just simply changed it to slope-intercept form. But it will be easier for us to manipulate. So we'll start with that equation, y equals 3x plus 4. Then if it is moved up 2, we simply add 2 to that. Now we'll simplify that. So the equation of our new line is y equals 3x plus 6. Look at the next one. If the line is moved down 5, please pause the video here and try that one on your own. After simplifying, you should have y equals 3x minus 1. Now 13 and 14 are a little more tricky because we have the parentheses involved. But let's begin with our original. We'll have y equals 3x plus 4. However, since we're going to have parentheses in this because it's moving right or left, write the 3 and then write your parentheses. Since we're moving right 4, counterintuitively, that's shifting -4. And then we'll also have our +4 from our original equation. Now, you don't have to simplify that. Please leave it just as it is so that we can obviously see that the equation has shifted to the right 4. Try the next one on your own. Since we know that we have moved left 6, inside the parentheses you're going to have a +6. Please box your answer, and the lesson is yours.